An important part of Bronsted-Lowry acid-base theory is the concept of conjugates. So we know that Bronsted-Lowry acid-base theory is all about a proton going from an acid to a base. And the conjugates are what we call the products. So let's take a look at an example that we've already seen to kind of get our head wrapped around this. So if we look at this example on the slide where we have our base, ammonia. We know it's our base because from left to right it accepts a proton. And here's water, reacts with water, which is an acid, which we know is acting as an acid because from left to right it donates a proton. So on the left-hand side of the arrow we have our base and we have our acid. And then on the right-hand side we have what happens after that proton transfer has occurred. Once ammonia gains that proton, ammonium is now an acid. And so ammonium is the conjugate acid of ammonia. Once water donates its proton, loses that hydrogen with no electrons, it becomes hydroxide. So hydroxide is the conjugate base. So on the right-hand side of the arrow, the acid and the base are known as conjugates. Now the difference between a conjugate acid and its base or a conjugate base and its acid is just a proton. The acid always has one more proton. So if we look at HCl, if that is our acid, then its conjugate base will be what we get after we remove an H+. So chloride is the conjugate base. You can always determine what the conjugate base is because you have to remove a hydrogen atom from the formula and then the charge becomes more negative by 1. Most acids don't have a charge, so their conjugate bases tend to have a charge of -1. However, sometimes an acid does have a +1 charge, and then its base will have a charge of 0, because 0 is 1 more negative than +1. If NH3 is our base, we add a proton to it to get our acid. The conjugate acid has 1 more hydrogen and a charge that is more positive by 1. So conjugates, just on the right-hand side of the arrow when we write out our acid-base reaction, and the acid will always have 1 more proton than the base. So the acid will have 1 more hydrogen in the formula and have a more positive charge by 1 than the base.